Oh, where are we recording? Oh, okay. Okay. Welcome back to Chemistry for Dummies. This week's topic is recrystallization with special guests Claire.
Hello.
Thomas.
G'day.
And Jacob.
Hello.
First off, let's start with a quick recap of what recrystallization is.
It's basically just a purification method. You take an impure chemical sample, it could be anything. You heat it, you dissolve it in a small amount of solvent, then you cool it basically and let it recrystallize, and then all the impurities from the original sample are left in your solvent. Pretty straightforward, really.
So, to demonstrate this, we're going to give you a quick example of how to recrystallize impure benzoic acid.
Before we continue, we are dealing with extremely dangerous chemicals such as impure benzoic acid and decolorizing charcoal. But let's move on from all that boring stuff. You need to get 10 ml of boiling water and a couple of boiling chips and put it into a flask.
Oh, sorry, my bad. After that, we then add about a gram or so of the impure benzoic acid into that boiling water. You'll notice that the color will change and go from the clear of the water to a pinky red color. That's this colorized impure substances inside of the benzoic acid. We got to get rid of that stuff, so we add in some decolorizing charcoal, which will absorb all of that, so when it's filtered out, it's all gone.
We then need to prepare some filter paper and just place it into a funnel, making sure to wet the sides so it sticks to the funnel. This needs to be placed into another conical flask and placing the whole glassware arrangement on top of a heat source, while keeping the second flask out of the heat source. Heat the benzoic acid solution until it's dissolved.
And after removing it from the heat source, the liquid should have passed through the funnel. You want to set this aside and allow for the crystallization to occur. Once the flask is cooled back to room temperature, it then needs to be placed into an ice bath. This cooling technique is used to make the substance of optimal purity.
Yeah, and then after your crystals are formed, you use what's the word? A Buchner funnel, there you go. Buchner funnel, and you filter off all the benzoic acid crystals using vacuum filtration. Once they're finished filtering, you just chuck them aside to dry at room temperature, around 10 minutes, but not much longer. Then once they're dry, you weigh it. So basically, the Buchner funnel is it places pressure on the substance so it drags all of the liquid out, and it's basically just another way to dry it, really.
Once this step is complete, the melting point of the substance is needed to be determined. This can be done using a melting point apparatus. The smaller the range of the temperature means the purer the substance.
So that's it for how you recrystallize benzoic acid after removing its impurities. But in this example, we just used hot water as the solvent. You don't have to use just hot water as the solvent. You could use any liquid as long as it follows a set rules of characteristics, and that is it must not react with the compound you're trying to purify, otherwise you'll end up with a new chemical substance. The compound must react better in hot versions of the solvent over a cold version of it. The solvent has to have a boiling point below the compound's melting point. The solvent should be reasonably volatile, and it should be non-flammable, non-toxic, and inexpensive.
I'm pretty sure there's another way to purify crystals. It's like sublimation or something.
Yeah, that's another podcast.
Oh, okay.
Alright, so just to quickly review recrystallization. First of all, the impure sample is added to a solvent. The solvent and sample is heated until the impure solid is completely dissolved. Then we go on to use the coloured charcoal, and it's added to bond to any insoluble impurities. This is filtered to remove the charcoal, and it's bonded into insoluble impurities. The filtered solution is allowed to cool and recrystallize. The newly formed crystals are filtered out of the solvent and dried, and then obviously a melting point is analysed to perform the test of purity.
That's it, guys. Thank you all for coming to this week's podcast.
Thanks for
having us.
Yeah.
Next week, we're going to have some new special guests on to talk about functional groups and aspirin synthesis.
Oh.
Cool.